In the summer of 1976, a NASA scientist sat in a control room in Pasadena, staring at a readout he had spent years hoping to see. His experiment, the one he had spent years designing to detect life on Mars, had just come back positive. A strong, repeatable response, exactly the kind of signal the experiment was built to find. He believed he had just found life on another planet. NASA disagreed, and for the next 50 years, the agency never sent another life detection experiment to Mars. This is the full story of the Viking mission, one of the most ambitious and controversial planetary missions NASA has ever flown. Because the question it raised in 1976 has never actually been answered. And in 2026, 50 years later, some of the world's leading scientists are no longer willing to let it go. To understand what happened on Mars in 1976, you need to understand what Viking actually was, because most people today have no idea how extraordinary this mission really was. In August of 1975, NASA launched not one, but two complete spacecraft toward Mars. Each one was a combined orbiter and lander, essentially two separate missions packed into one. They were called Viking 1 and Viking 2, and together they represented the most complex robotic operation the United States had ever attempted in deep space. In today's money, the total cost would be somewhere around $6 billion. The journey took 11 months and covered roughly 500 million miles. Viking 1 entered Martian orbit on June 19, 1976, and immediately began doing something that had never been done before: photographing the surface from above, not for science, but to find a safe place to land. The original touchdown was planned for July 4th, timed to coincide with America's bicentennial. But the orbital images showed the planned site was too rocky, and engineers scrambled to find another. The new date ended up being July 20th, exactly 7 years to the day after Apollo 11 touched down on the moon. At 8:12 in the morning Eastern Time, the signal arrived from Mars. The lander had touched down on a flat, rocky plain called Chryse Planitia, the Golden Plain. Within 5 minutes, the camera activated, and an image began building on screens in Pasadena, pixel by pixel. One footpad resting in reddish dust. Rocks scattered across a cold desert. A salmon-colored sky above the horizon. The surface of another planet, seen for the first time in human history from ground level. Viking 2 followed 6 weeks later, setting down in a region called Utopia Planitia, nearly 4,700 miles from its twin. Both landers carried the same suite of scientific instruments, including the experiments that would start a controversy that has never been resolved. Viking carried the first biology laboratory ever sent to another planet. 3 separate experiments, each designed by a different team, each looking for life through a different method. The first was the pyrolytic release experiment. It exposed Martian soil to radioactive carbon dioxide and carbon monoxide, then checked whether anything in the soil had absorbed those gases, which living organisms would do as part of photosynthesis or basic metabolism. The second was the gas exchange experiment. It added water and nutrients to a soil sample and measured whether any gases were produced or consumed in response, the kind of chemical activity microbes generate when they eat and breathe. The third was designed by a scientist named Gilbert Levin, and it was called the labeled release experiment. The concept was simple. Take a tiny sample of Martian soil, add a few drops of nutrient solution made from basic organic compounds, the same building blocks present in the early chemistry of life on Earth. Tag every molecule in that solution with radioactive carbon-14. Then wait. If there are microorganisms in the soil, they will metabolize those nutrients. They will process them and release radioactive carbon dioxide into the chamber above. The counter will spike. On July 30th, 1976, 10 days after landing, the counter spiked. Both Viking 1 and Viking 2, separated by 4,700 miles of Martian terrain, returned the same result. When soil was sterilized by heat before testing, the response disappeared, exactly as it would if living organisms had been killed. When fresh, unsterilized soil was tested, the response returned. By every criterion Levin's team had established before launch, the labeled release experiment had detected life on Mars. Then came the problem. The other instrument on board, the gas chromatograph mass spectrometer, designed to detect organic molecules directly in the soil, found nothing. No organic compounds, essentially zero. And the scientific establishment decided this was the definitive answer. No organics, no life. The labeled release results had to be caused by something else. Some exotic chemistry, some unknown oxidant in the Martian soil mimicking biological behavior without actually being alive. NASA's official conclusion, delivered in 1976 and largely unchanged for decades, was that the biology experiments had produced inconclusive results, and that chemistry was the more likely explanation. Levin never accepted it. For the rest of his life, he died in 2021 at 97, he maintained that his experiment had worked exactly as designed, and that no non-biological explanation had ever fully accounted for every data point. Then, 30 years after Viking landed, something changed. In 2008, the Phoenix lander detected perchlorates in the Martian soil, highly reactive chemical compounds that, when heated, destroy organic molecules. They burn them up before they can be detected. The gas chromatograph mass spectrometer had heated Martian soil to analyze it, which means the very instrument NASA had used to rule out life may have been incinerating the organic evidence before it had a chance to measure it. Scientists who went back and reanalyzed the Viking data found that the absence of organics was entirely consistent with organic molecules being destroyed by perchlorates during heating. The negative result that had overridden Levin's positive one was itself potentially flawed. The case was reopened. What makes the Viking story so strange is not just the original controversy. It is the fact that it took 50 years for the scientific community to look at it seriously again. After Viking, NASA shifted strategy. Instead of searching for life directly, the agency focused on water, the logic being that you establish habitability before you search for inhabitants. It was defensible science. Over the following decades, mission after mission confirmed that ancient Mars was far more hospitable than anyone had imagined. Dried riverbeds, mineral deposits that only form in liquid water, ancient lake sediment containing complex organic molecules. Mars had been, for hundreds of millions of years in its early history, a world where life could plausibly have existed. What none of those missions had was a biology experiment. Not one dedicated life detection instrument was sent to Mars after Viking. For 50 years. Recent analysis published in the journal Astrobiology, led by scientists from the Foundation for Applied Molecular Evolution, directly challenges the inorganic chemistry explanation for the Viking results. Their argument is specific. The labeled release experiment showed behavior, including the reduction of response in sterilized samples and consistent results across two separate landing sites, that is characteristic of biological processes and difficult to account for through chemistry alone. In the absence of a non-biological explanation that satisfies all the data, they argue, biology remains a viable explanation that cannot yet be ruled out. As of 2026, NASA is holding a major event in July to mark the 50th anniversary of the Viking landings. Researchers are openly revisiting the Viking results in ways that would have been unusual even a decade ago. The conversation itself is a shift. Step back for a moment and consider what any of this actually means, not just scientifically, but practically. If microbial life exists in the Martian soil, Mars is not a sterile environment waiting for human colonization. It is a biosphere, however minimal, with chemistry already in motion. That changes things considerably. Perchlorates alone are a serious practical problem. They are present across the Martian surface at concentrations toxic to humans. They disrupt thyroid function, and long-term exposure at Martian soil levels would be dangerous. Any habitat, any agriculture, any surface operation would require dealing with them. Some researchers have proposed using perchlorate metabolizing bacteria to clean agricultural soil, the same kind used in certain earth bioremediation applications. But that solution requires first confirming that you are not introducing earth biology into an environment that may already have its own. The contamination problem runs in both directions. Martian microbes, if they exist, have spent billions of years adapting to extreme radiation, extreme cold, and perchlorate-saturated soil. They may be extraordinarily resilient. How they would interact with human biology is unknown. And any Earth organism that survived spacecraft sterilization and reached Mars would potentially corrupt the very biological signal scientists have spent 50 years trying to detect. This is why the life question is not background noise for a future Mars mission. It is foundational. The answer changes how you build, where you dig, and what protocols you follow from the first day on the surface. By almost every technical measure, Viking was a complete success. The two orbiters mapped 97% of the Martian surface. The landers returned more than 4,000 photographs, recorded weather, analyzed the atmosphere, and operated far beyond their designed 90-day lifetimes. Viking 1's lander stayed active until 1982, more than 6 years after landing. What Viking never delivered was a clean answer to the one question everyone actually cared about. And the debate ultimately came down to interpretation. Specifically, the decision to let one negative result stand as the final word over a positive one that nobody could fully explain away. Levin spent 4.5 decades asking the scientific community to look again at his data. He is gone now, but the data is still there, unchanged, in the archives. Two landers, 4,700 miles apart, the same result, 50 years ago. In July 2026, NASA will mark the anniversary of the Viking landings. New papers are being published. A major book on the Viking biology experiments is being released to coincide with the date. And researchers who have spent careers on this question are saying, with more institutional weight than ever before, that Viking may have found exactly what it was sent to find. The question of life on Mars was never closed. It was only set aside.